fine. The target acceleration, that's fine. That's normal. I'm using Excel spreadsheet to learn more about the acceleration. You can download this link here. Okay. So seeking values. All right. So we can download the initial velocity of an object at rest. What is the velocity of the object at 1 second? 2, 1 second. Okay. I guess we can do this. I don't know if that downloaded. So that's not good. Let's do save link as, maybe that will help. Okay, that did help. Uh, oh boy, I guess we'll keep it. Okay, I'm just downloading it and then opening it. Right, so fortunately the file, I can't download the file. So you will need to email your instructor about this link. The issue appears to be that it's some sort of, there's a protected issue with this link. You know, and Google probably doesn't think it's safe. I'm really surprised that it didn't open. Let me try it one more time. It's also the wrong file type. It's from like 7 years ago. Nope, there it did. It did open. Okay, maybe we are in good shape. Okay. So we can do this. We can do this. So we've got the spreadsheet. We can answer the questions. I do want you to do the formal lab report. So what are you doing in this lab? Okay. Different objects that will not be damaged when being dropped, such as balls, ping pong, coins, coffee filters. Okay. 2 meters stick or tape measure. Do you have any of these materials there
At,
with you?
at home, yes.
At home, yes. Okay. Step stool, stable chair, reach height of 2 meters. Stopwatch, here's the online stopwatch. Find ways to mark heights of 1 meter, 1.2 meter, and so on, which will drop the object. Um, take the object that has the biggest size and release from a height of 1.5 meters. Measure the time it takes at the ground. Repeat the experiment. So you have 3 different measurements. The same quantities will help account for slight variation. Okay. Feet 1 to 3 more times for each object. Then you have to vary the heights. Okay. So the same thing when you vary the heights. Uh, then you got to do some sort of a chart, take some pictures, so on and so on. Okay. Yeah, I mean we can certainly work through this. Let me start by grabbing the lab template for the, where is the lab template? Uh, there it is. Okay, so there's the template. Let me grab this and put this into a document. Okay. And then the first thing it says here is to answer these questions. But where do we answer them? I guess we'll put them in the I don't know. I guess we'll put them in here in section 1. Okay. So let's let me go ahead and switch sharing to something else. Really surprised they have you do a lab to start, but that's what they have you do. Okay. The spreadsheet starts with the object at rest. what is the initial velocity of an object at? Okay, so when it's at rest, it is not moving. So what is your speed if you're not moving?
Like, well,
Like
if
you're
you're
not
not moving,
moving.
then you're not moving. So your speed is nothing, no?
Yes, so we could say zero um, for that. That's the speed, 0 meters per second or just zero. They are using meters per second. Okay. So the next part of the question is to find the velocity of the object at 0, 1, 2, 3, 4, and 5 seconds. Uh, the way to do this, let me go share that other screen. So we're looking for at 1 second, we want that right there, that value, 9.8. Does that make sense?
Yeah.
So maybe we'll put that in the chart here or in this other thing. It's 9.8 meters per second. What is the velocity at 2 seconds?
At 2 seconds, it says it's like 20.
19.6.
Well, sorry, 19.6.
Okay. And then at 3 seconds, do we have one at 3 seconds? Yes.
So that's like 29.4
Yes. Okay. And then what's going on at 4 seconds?
at 4 seconds. It's all the way down, so it's zero.
Yeah, so what do you think's happening there? What do you think is causing it to go back to zero?
Gravity.
Okay, a little more than that. What happens when you fall?
Uh, when you fall, you go land back on your feet, like or on your. Well, it just depends. Actually, sorry. Well, when you fall,
So
oh,
eventually you
how
hit the
does?
ground or
Yeah, you hit the ground.
that's what this is showing here, like your height, eventually you're on the ground, so you're not moving. The velocity is getting higher and higher once you hit the ground, and then you're no longer moving.
Got it.
Okay, so let's go back to the other screen here. So I'd like you to answer this question here. Look at the first 4 values. What is the difference between each of those first 4 values?
What's the difference? I think the difference is like the height that they're at, like
No, just
during
numerically, what's the difference between each of those 4 values? What's the difference in them?
the difference is the the seconds that they're in the air.
I'm just asking you to subtract the numbers one
Oh,
from the next.
one from another.
Yeah.
So basically, you want me to do like 19.8 minus 19, like that.
Usually it's like the next. Oops, let me put it down here. The next minus the previous, or you can think of it as the new minus the old.
Okay, so what I would have to do like 0 minus 9.8, then
Nine
minus
nine
19.6.
nine 9.8's the new, and the 0 is the old.
Okay, got it.
And we're just trying to figure out what it's going up by each time.
So it says it, so I did it and it's going up by 9.8.
Yes. So 9.8 is the acceleration due to gravity. Okay, so I'd like you to put together a sentence that says, for the first 4 seconds, the velocity increases by 9.8, which is the acceleration due to gravity.
All right, let me just retype that. So you want me to retype number two, just making sure, right? I don't want to get confused.
Yeah, I want you to talk about, they're asking you basically what's happening in the first 4 seconds. 3 seconds, sorry, 3 seconds. And that the velocity is increasing by a constant amount. It's going up by the same amount each time.
Here's what I wrote. I'm not sure if I worded that correctly though.
So you've got to say something about the first 3 seconds. Like in the first 3 seconds,
Oh, okay. So like in the first 3 seconds, it goes up, the velocity goes up by 9.8.
yes, each time, and that happens to be the acceleration due to gravity.
Okay, here's what I wrote this time. I added the 3 seconds, but I don't know.
Okay, so I'm gonna modify what you've got here. Um,
That's fine.
this is kind of what they're looking for in the first 3 seconds. The difference between each of the velocities is constant at 9.8 meters per second, which is also the value of the acceleration due to gravity. Okay. Um, we then want to, we then want 5 seconds, or what happens somewhere between 3 and 4 seconds. We already alluded to that in the picture. What happens?
In the picture, well, it goes up and then it just drops.
Okay, so we should
Like
say my internet just went unstable. Okay, we want to say that. We want to say that between 3 and 4 seconds, the object hits the ground, so it's no longer moving.
all right. During the 3 or 4 seconds, the object hits the ground and stops moving. That's what I should write.
Something about that, yeah. Something about it hitting the ground.
All right. So something like what I wrote in the chat, right?
Go look here. So it's between the third and the fourth second. I'll modify this. So between 3 and 4 seconds. So you already have that. The object hits the ground and stops moving. Good. So thinking back to and you kind of already said it here, this word constant. You want to say that the uh, it's actually that the acceleration is constant.
Mm-hmm.
I don't know how you're supposed to know that. So the acceleration is constant while the object is in motion. Okay. Set the slider for a number of different values, especially small ones like 1 meter to 3 meter, and look at the height versus time graph before answering the parts of this question. Describe the shape of the height versus time graph. What does the shape of the height versus time graph tell you about the motion of falling object? Okay, so we're going to go back and look at that Excel sheet again. So it says to change the slider. Oh, there, that is the slider. Okay. Change the slider 1 meter to 3 meters. Look at the height versus time graph before answering this question. Okay. This is the only slider I see. Um, do you see any other sliders? Just that one.
No. Oh, there it is. Whoa.
I guess they used a macro for that. Okay. this is not a very helpful question. The graph's not really helpful. But would you want to take a guess at what type of equation this is? Um, let's see if this is okay. Describe the shape of the height versus time graph. So okay, let me do a little better job here. So let's say why is it okay? So at 10 meters, I guess that's the first one. So starts at 10 meters and goes down. Okay. Um, and you said you're jumping into pools and stuff.
Yeah.
Okay. So if you were to look from the side of the pool to see someone jump in, do you think that their shape looks like that?
Yeah, if they're diving in, that's exactly how it looks.
Okay. How about the, is that kind of how it looked?
Yeah.
So does the shape change no matter what height they start at?
I think
Generally,
like yeah, generally.
generally stays the same. So any idea what parent function this might be?
Uh no.
Like, let me put something in there in the chat here, maybe help.
Okay, let me look. Oh, that looks more like from on the chart. Well, it looks like the square root one
Well, it's kind of
from
a backward square root.
yeah.
What if you were to turn this quadratic upside down?
It would be an inverse, right?
Yeah. Quadratic squares are somewhat related. So the motion, what they're looking for the answer here is that it's quadratic. I mean, they're looking for some sort of that's the key word they're looking for. So they're asking you to describe this shape right here,
Okay.
and it's quadratic. I mean, it's let's see, one. I guess that's easier to see. 1.2. So they're trying to get you to see that that's quadratic. It kind of falls down pretty rapidly. So could you put a few words together now that describe kind of it falling in this quadratic shape?
The quadratic shape looks like a
There's a letter that it's often referred to with a quadratic.
oh, really?
Yes, like an upside down U or U shaped.
Oh, so it's oh, I know. It's like oh, okay. Okay, so it's like so it's either the quadratic or inverse kind of one. So wouldn't it still be
Upside down would um,
oh, upside down. Okay.
be the preferred word.
Man, I don't know why it's okay if I so like I was about to say exponential, but I don't think that's right.
It's got you got to say quadratic, and you're trying to describe the shape, which is an upside down U. But I'm looking for a few
Yeah.
words to describe that sentence if you can.
Okay. So like I should start off saying the quadratic shape is like an upside down U.
Yes. You're trying to describe this first region of the graph. Like, what do you see happening?
Wait, isn't it like the upside down? If it's like the quadratic, but like upside down, isn't it negative? Usually when um anyway, I just wrote the quadratic shape is formed like an upside down U. Is there anything else that I should add?
Well, I'm just trying to get you to describe what you see in your own words in that first part
Okay,
of the graph. Um,
so that's
like
what I.
imagine you're just trying to describe that picture that I put in the chat there.
All right.
Like that's all. Like everything you said is fine, but what you gave me is more of a definition. Like you're not talking about the object
Okay.
falling. You're not talking about kind of like how far apart the squares are or
All right, here's what I wrote.
okay. Yes, this is much better. Much better. Okay. I know this is probably challenging. I'm trying not to just give you the answer code that
Yeah.
I'm looking for because I just don't think that's the right thing to do here. Okay, so the next thing here is that it asks, what's it? Copy and paste. Okay. Wow, I'm having all sorts of problems. What does the shape of, we kind of already answered that. I tell you about the motion of the object. Okay. Trying to decide how to get you to answer this next question. Let's do the following objects. All right, let's go back to the other screen. Okay, there, the uh the motion of the following object is not constant acceleration due to gravity? I don't think there's another way to answer that. Um, okay. So now the next thing here is we're going to look at the slider. We're gonna change that slider again, but this time we're going to look at the velocity versus time graph. And velocity. Okay. Let's go back and look at that. Okay, so look at this graph here. What do you notice about if you were to connect those dots? What would you notice about that shape of that? What would you call that?
Like not like it's not a straight line, it's like a
Looks like a straight
just
line.
yeah, I forget what it's called, but
What is this?
it's like a slash basically.
Okay.
Like
So
you
the
know on your
slope is,
keyboard.
yeah, the slope is changing, maybe. Um,
Yeah.
maybe. But what what do you what do you notice about this? Is it ever not a line?
No. I mean, yes, it always is a line, but it never
Yes.
changes.
Okay. So uh let me put this into the other screen here. Let's see if we can answer this question. Share. Okay, so it says describe the shape of the velocity versus time graph. So you just have to describe what you see here. And it's all the words we just said while we were talking. Line, constant slope, um, going up and to the right. Any of those words would work here. So it's a line, constant slope, up and to the right. Any of those words would be good to include in this.
They want me just to describe how the slope never changes, right? All right, here's what I typed.
Okay. All right, so now, next one, uh, the word you have to use here is constant slope. It's like, it didn't matter for question number two, it didn't matter whether we had a, what height, it always had a line that went up and to the right. That's constant slope. So you have to incorporate that word into your answer here. And you can basically just say the shape of the velocity versus time graph always has constant slope. You could also add in here that the velocity increases by the same amount for each second the object is in the air. That would also be good to include. So give me a sentence or two for that, please.
Okay. Okay, this is what I wrote. I kind of paraphrased what you wrote in a sentence, and I just went from that.
Okay. There's one little rewording here that's needed. Let's see here. Okay, the slope of the velocity increases by the same velocity is constant, or it's that the slope is constant. Um, and the velocity changes by the same amount for each second the object is there until the object hits the ground. Okay. And then what does it look like when the object reaches the ground? I mean, we've talked about this over and over again. Like, what happens to the object once it hits the ground? What's the velocity?
Like the velocity is it goes from 2.5 to 4.5. What?
This is time.
Zero, sorry.
Yes, the velocity. That's the second question. It's zero when it reaches the ground, but does it ever change?
No.
So it's still constant. It's just constant zero. Yeah. All right. So let's stop there. We really can't get into question five. There's no issue with us trying to continue working on this lab. Um, you might even be able to do some of it there, although I'm guessing you may not want to. You don't have to actually measure the exact heights, but if you had some balls or some other things that you could drop, um, it could be fun to do. But I'll leave that up to you. So we're going to stop here for today.